Hello, welcome to my channel. If you look at the spectral waterfall, you'll see a couple of signals just sliding off the bottom that are not from me. That one's from me, the big red one, because it's very close, so it's very strong. That one's even closer to the antenna and even stronger. But those other two signals that have gone off the bottom of the screen now, they are other users of the spectrum being received here. And I show you the antenna I'm using, which is that. Is a discone antenna, wideband antenna, which I actually made myself with brass rods soldered together, and quite an entertaining project. I'm trying to get all that together without bits dropping off as you heat them up. Anyway, I'm waiting for other signals to pop up again. I started this video very fast without an introduction because they don't appear very often, so as soon as I saw them, I thought I'd grab them. Those very strong signals are my ones, which are being sent between these two devices, this top one, and which has a RNode radio node on it for Reticulum, and the one below which doesn't have an RNode, but it's communicating via the LAN at my place to another machine which does have an RNode, is acting as a bridge. So it's a 3-node setup at the moment. And what I wanted to show is that there is some usage of the radio spectrum. Let me just change this view so I can move the mouse around. These little pips here are very short bursts of data that are being transmitted, and you can see that Reticulum is sending much longer bursts of data. These are so strong, of course, they wipe out the view of anything else and desensitize the receiver. Occasionally there are some longer bursts actually on this frequency as well that look similar to my ones. I don't know, I don't think anybody else is actually using Reticulum near me, so it must be another system, but you never know. I'm waiting for them to pop up, and they're not. So I'm glad I started the recording suddenly with no introduction so that you could see them as they went off the bottom here. I'll talk for another minute or two and see if they do come up again, but they may not do. Whilst we're waiting for that, it's like waiting for shooting stars. Let me just go back to this other view so I can see what I'm doing. From this machine, something else I want to show you is ping, the ping command, because you can ping just like you can with Ethernet, TCP/IP rather. So I can ping this destination, which is the bottom left-hand window, that machine where I've been sending messages backwards and forwards in an audio clip. If I do ping, we'll see how long it takes. And you can see the ping message being sent out by the bigger signal there, and then the smaller signal without the white splatter is the other side responding. And what we've got here is a valid reply with a ping time of 1.9 seconds, which shows it's gone via the LoRa radio link. There's no internet connection on this device. You can see maybe it's tiny, but it's in airplane mode. Wi-Fi is turned off, and there's no Ethernet connection, so it went via LoRa. I'm just wondering why there are 3 hops. I need to count the hops, don't I? So how is this working? This machine has a LoRa RNode, goes to another machine, that's 1 hop. That machine then goes to this machine, which is 2 hops through my LAN network. I'm not sure why it's 3 at the moment. That's very odd. I did this a few minutes ago and it was 2, not 3. So that's a little bit of an anomaly. What I can try is using the machine in the bottom left-hand window and see what that does. Where is it? I've got a lot of windows open here. It's this one. Let me ping in the other direction, see what it says. And you have to wait a second because it's going via LoRa. Oh, 2.7 seconds and 3 hops, although I think it should be only 2. 1, 2. That's odd. Reminds me of the time that, that's a long story, but somebody was printing something to a printer on their desk and the ping time was too long. It turned out it was going via someone else's desk in Russia and printing out in parallel. This was a US problem. Anyway, I'm going to have a look at why that is. There are 1 or 2 other RNS commands you can use that are a bit like ping, so I'm going to try those and see if I can see what's happening here. So what I'm going to do is just ping from one device, that one there, not to the one on the lower left-hand corner of the screen, but to the other radio node. So it's radio to radio via LoRa, should be 1 hop. Let's just ping that, see what happens. To X230A, and ping time 1.5 seconds, and the hops is 1. That's what I would expect. What I did was I went over to X230A and pinged to the other machine that's in my LAN, which is the bottom left-hand one in the screen you can see, and that should be 1 hop as well. It was actually 2 hops, and I used the rnpath command to find out what was going on. And by using rnpath, which I'll show you in a moment, I could see it's actually going via, it tells me it goes via another LXMF address on TCP interface RNS testnet between the borders. So it's using one of the RNS testnet interfaces to get from one machine on my desk to the other machine on my desk, because I've configured it like that and I'd forgotten about it. It's interesting what can happen. It's starting to get dark here, so I think I better switch the light on, but then you'll see the background from behind me change. Sorry about that, so stand by. So, sorry about the change of lighting. You don't need to look at me anyway. So what I'm going to do is to use the rnpath command to find out what's going on. This is where you need to be running Linux. So this is the rnpath command that finds the path to another node in a reticulum system when you just put in the hash for the node, which you can copy paste. I'll show you where from. Up here, you just copy paste this. So the one I'm about to talk to is the other one, which is not this one. This is quite complicated, having so many machines running. That one. Those are the 2 LXMF addresses anyway. So I'm going to use rnpath. So let's try that one. What does it say? It's 1 hop away. That's what I expect. Via, it's going via this same node hash or identification on RNode interface 1. I've called it RNode 1. So it's a direct LoRa radio link, and it's 1 hop, which is what I expect. From one machine on the desk to the other machine via LoRa is 1 hop. The problem is, well, it's not a problem, but the thing I noticed was when I tried to go to the other machine on the desk, which is connected via LAN, which should make 2 hops then because it goes 1 radio hop and 1 LAN hop, what I get is an answer of not 2 but 3, and that's because it's going via another node with this hash. I haven't worked out what this one is yet. It's one I've set manually in the config file because I thought it was a good one to use. So it just means that between 2 machines in the same LAN on the same desk, the data is being routed through this extra address because I've set it like that for another experiment and forgotten about it. So this rnpath experiment command is very useful because you can see if you've got more hops than you expect what's in between. I haven't tried it with 4 hops to see if you can get 2 hash addresses here, maybe. The other command that's useful is rnprobe, and that gives more information about the other end of the link, but rnprobe is turned off. The response is turned off by default in the config file. I did try turning it on one machine and rnprobing it, and it didn't respond, so there's obviously another setting I haven't found yet. Well, that's enough about these settings, and certainly the rnpath command works on all the nodes I've tried, and that's very useful. So you can see how complicated things get. I'm still waiting for more signals to pop up in that band, and as you can see on the spectrum display, there are a couple of very short little blips, but not any long ones like Reticulum, except the ones at the very start of the video, who will probably never do it again. Okay, that's enough from me. Remember to like if you did, and subscribe if you want to be notified of more videos, and see you in the next video.